We already touched on this, pointer arrays and pointers to pointers, but I want to repeat it again because I want you to make sure that you understand that you can do these kinds of things. And it's quite powerful, and you may find a situation in a program, you certainly will if you're dealing with database records and lots of records of similar data that you need to compare to one another, and you don't want to move all of the data all the time. I mean, that's the most inefficient way to go. What we're going to do is we're going to talk about a pointer as just another variable. That's all it is. A pointer is a variable that can contain the address of some place in memory. We already know that. Well, since a pointer is just another variable, it can also itself be manipulated. We saw how we do pointer math. We can add numbers to pointers. We can subtract one pointer from another and so on. But one of the things we haven't looked at is radically changing the value of a pointer, even swapping the addresses between multiple pointers. For example, if we have an array of pointers, think of it as a large group of pointers, each of them pointing to an element or an individual row in a database. The columns can be compared, I want to say, and then the pointers swapped with one another rather than swapping all of the data values. That's an easy way to do a sort. You sort the pointers into the order that you want and then run down through the index list of pointers and retrieve the data in the correct order that is necessary for your application. Let's take a look at a piece of code here. Not a piece of code, but just a table. Here's 3 database records, and there are addresses on the left column, and on the right column are the database records. Well, all you have to do is go through and compare, like I said, the various columns in the database records, whether it's a state or a last name, first name, a price of something, whatever you're looking for, and then when you find 2 that are out of sequence, you switch the contents of the addresses in the array there on the left side. Those are all pointer arrays. So by switching those values around, you can actually resort the database table without sorting the database table. If you're familiar with databases, that's just an index. That's all it is. But we're going to create those indexes in memory using pointers, arrays, and then pointers to pointers, because you can use another pointer to sequence down through this table one at a time, incrementing it, and since it is created as a pointer to a pointer, it will increment by the appropriate number of bytes to go from one pointer to the next one.